Now, a fellow from Russia by the name of Dmitry Mendeleev a few years ago developed a chart. It was called the Mendeleev chart for quite some time, the Mendeleev table, and today it's pretty well accepted as the periodic table. Um, he discovered that elements could be classified by the number of electrons on their outermost shell. And in the first column of this chart that he put together, he grouped the elements with one electron in the outermost shell. As I mentioned previously, hydrogen exhibits that characteristic, as does these elements. You have lithium, sodium, potassium, rubidium, cesium, and francium. Now, their decreasing atomic weight from bottom to top is the pattern that you have here. Francium, atomic weight-wise, is quite heavy, and hydrogen, as has been mentioned previously, is extremely light. Now, many people want a feel for why hydrogen is so important. Even though hydrogen on the Earth, or in the Earth's atmosphere, and pretty much Earth's plate also, only comprises about 0.00005%. Hydrogen is the dominant element throughout the universe. How dominant? Get yourself the sharpest pencil that you can sharpen. Go to a wall, back wall if you wish, and put a dot with that pencil. So your dorm counselor, your mom, or whoever's watching that sort of thing can't see it. Make it really small. That constitutes all the elements except for hydrogen. Now, how prevalent is hydrogen? Hydrogen is the rest of the wall expanded to the extent of your neighborhood, the whole neighborhood. And that little dot not only comprises the rest of the elements in the universe, but it's all of the masses of all of the rest of the elements in the universe. All the stars are glowing hydrogen balls. So hydrogen is a very small quantity in the atmosphere of the Earth, but as far as the universe goes, hydrogen rules. It is by far the most prevalent of all the elements. All right, let's talk about the chart a little bit. Dmitry said that there are 8 columns across the periodic table of the elements. He said that hydrogen leads 1, and then in the next column, obviously having how many electrons on the outermost shell? 2. Okay, and these elements now this column 2 contains beryllium, magnesium, calcium, strontium, barium, and radium, which you can easily look up. But the point being that they contain 2 electrons on the outermost shell of the electrons that are available. As we move across, we're not going to talk about all of the different columns of elements today. We're only going to center primarily on column 1 and column 6. But Dmitri in column 6 came up with, again, another important element. And that's oxygen, of course. Oxygen, sulfur, selenium, tellurium, and polonium comprise this. Now, this is column 1, column 2, column 6. Repeating, the elements are oxygen, O obviously, S is sulfur, Se is selenium, Te is tellurium, and Po is polonium. Now, Dmitri had some difficulties along the way. He discovered that there is a problem with his chart in that the electrons form full shells when they're combined together to form compounds, but there are some naturally occurring full shells. And these naturally occurring full shells, which are absolutely important in all of this, are the elements that we refer to as the inert elements. They have, with the beginning element of helium, and they're over here in column 8 because they're out of the way that way. And the first of these is helium. Helium, neon, argon, and xenon. Now these elements, this one contains 2 electrons in the outermost shell. By the definition of interaction that I've already explored, if it's got 2 electrons, that's a full shell. So it should not react with anything else, and it doesn't. And we refer to it as an inert element. And Dmitri discovered that most of these, later it was confirmed that it was all of these, are gas. So we refer to these as the inert gases. And helium, neon, argon, radon, and xenon are referred to as inert gases. Helium is reasonably common, maybe not quite as, let me double check here, I'm just missing something. Okay. Mendeleev has been heralded much more in the last few years than he was previously, because he was, I know I was missing something. Right here, you have Superman, krypton. Those of you that follow Superman comics know that helium, neon, argon, krypton, radon, and xenon. So there is a krypton, but it's an inert gas. It's not a green metal that Superman uses as his death spiral, something that makes his powers inactive. So these are the elements in the inert gases. I knew there was one short there, and I had to hunt it down. Now, as is obvious from the beginning, if you react column 1 and column 6, you only have 7 electrons in the combined outermost shells. Oxygen has 6 and hydrogen has 1. So it's 7. So if you're going to form the molecule for water, you're going to have 2 hydrogens. And we will chat about that